Hello, I'm Jake Hartman, and I'll be presenting the project description. Not much has changed since our preliminary review, as our sponsor still has the same requirements. Although, the sponsor gave us the opportunity to switch our main goals for this semester, we decided not to, in order to ensure a complete working deliverable. Our project, Small Worlds Mobile, is sponsored by ASU's Center for Education Through Exploration. We have been working with Joseph Schindler, the center's game design lead, who first developed the Small Worlds Infoscope project. Small Worlds is a space exploration game developed in Unity 3D using WebGL. The game lets players explore our solar system and collect data on small worlds. Throughout the game, players will be able to observe motion of different worlds and learn how to determine its location in the solar system. The player completes the game by finding the hidden caches, called Astro Coins, on all the small worlds. Our goal is to deliver a working version of the game with modern touch controls that is playable on Android and iOS devices. To do this, we were given access to the full source code via GitHub, and each team member has a GitHub webpage that is connected to the Smart Sparrow platform in order to test our individual tasks. Tasks will be broken down into detailed sprints described later into this presentation. The purpose of this project is to reach a larger audience, specifically schools that do not have the funds for computers for every student. Our final deliverable will help enable the ETX Center to further their goal of creating accessible and interactive learning applications for educators and learners of all ages.
Hello, my name is Nolan Bruce, and I'm going to cover our original design and architecture goals and discuss what has changed since our preliminary design review. Our main design goal remains to emulate what occurs in the desktop version of Small Worlds on a mobile device. Similarly, the architecture essentially remains the same as before, where the Unity 3D WebGL module interfaces with the Smart Sparrow learning platform through CAPI. The backend for touch controls was implemented using a combination of Unity 3D's built-in component-based architecture and an additional asset called Newline Touch. This was introduced in the first sprint last semester and refined in the second sprint at the start of this semester. With this, the design and architecture essentially remained the same, but with an additional method of control. Beyond this, we'll be moving to support portrait mode in addition to the already supported landscape mode. This will involve redesigning the GUI to work with just about any resolution. Currently, practically any landscape ratio is supported, but we'll be redesigning the layout of the GUI elements, primarily through anchoring and resizing, to support displays in portrait mode as well. One significant task we're undertaking relating to design and architecture involves the save state system, the backend CAPI, and Smart Sparrow, a design platform that the Unity 3D WebGL game interfaces with to create and record progress in the educational simulation that is Small Worlds. Currently, there are issues relating to restarting the game or refreshing the page that can result in breaking the game. To fix this, we'll be redesigning a save state system that ensures that the game always loads back into the correct state and never leads to a state that doesn't match the progress that has been made by the user. To do this, we'll have to modify the existing save state architecture to ensure it saves all data required to return Smart Sparrow to the appropriate point of progress. Also relating to the Smart Sparrow architecture, we'll be redesigning the GUI through CSS and JavaScript to remove and/or alter buttons that use methods that are soon to be not supported by the platform, as well as adding a button for a new full screen feature.
Hello, my name is Jacob, and I'll be going over the timeline and milestones for the Small Worlds mobile project. The original and modified timelines are listed under the two main headings, with the dates of the sprints and the name of the milestones indented below them. Our original plan for our sprints was to break them down by major project milestones, which gave us 3 sprints for the semester of roughly equal work. The first sprint had a focus on fixing bugs and refactoring, the second focuses on a rebuild of the GUI for our mobile game, and the third will focus on speed of deployment and optimizations for our game. The initial timeline can be seen above, with Sprint 1 lasting for about 26 days, Sprint 2 for 27 days, and Sprint 3 for 27 days. Within the first couple of days of Sprint 2, we realized that we had a major bottleneck on what work could be done and had to quickly come up with a plan to rectify the situation. Together, our team, with our sponsors' input, ultimately decided that it would be in our best interest to combine the last 2 sprints. The new schedule is shown in the slide only differs in the merging of Sprints 2 and 3. For this newly combined sprint, we have a total of 5 primary user stories, not including finalization and potential bug fixes. The stories are GUI scaling and anchoring based on mobile device size, streaming video on mobile devices, game optimization and asset bundling, Smart Sparrow relayering and full screen viewport, and finally saving and loading the current game state. These user stories bring together the remainder of our milestones for this semester and the Small Worlds mobile project. A rebuild of the GUI will allow the game to operate on a plethora of devices, and the optimization of the game will ensure classrooms full of students will be able to play together flawlessly. Now that we have combined our last 2 sprints, we see a much easier path towards our ultimate goal, and I expect to once again pull ahead of schedule to ensure we have plenty of time to iron out any bugs remaining in the game upon implementation of the remaining changes.
Hi, my name is David McDonald, and today I will demonstrate how we have handled risk management with our project. We have encountered a few risks this semester while working to overcome our obstacles. We have found that bottlenecking and sprint task dependencies have proven to be an issue when we have moved through the semester. The original plan for this semester was to split the remaining user stories into 3 clearly defined sprints. At first, we believed this would help an even distribution of the workload and make our project better. By limiting the scope of each sprint, we might also increase the amount of bottlenecking. We have reviewed our sprint number 2 and introduced the goals for sprint number 3 to avoid this issue. We still have a few sprint task dependencies, but this cannot be avoided at this time. Throughout the entire project, we have had issues with conflicting schedules. This is an issue that has no easy solution, but more healthy group communication should solve the problem. We believe that by identifying these risks and creating solutions is our best option during the project. Not all risks present themselves when we plan something, but taking the time to find a productive solution has proven to be well worth the effort. As a group, we believe that we have established good techniques for eliminating project risks as they occur. The most important part of risk management seems to be identifying the risk and discussing the issue with teammates to make a solid decision.
Hi, my name is Crystal, and I'll be giving this portion of the review on insights. The process we are using to complete this project is a modified version of Scrum. We have been using Taiga to track our progress on each sprint. Each user story has several tasks associated with it, and every member is expected to be working on at least 1, but no more than 2 tasks at a time. We're using GitHub to modify the project script, and GitHub IO to test functionality. Recently, we have been given access to the Smart Sparrow platform to implement changes that cannot be done with Unity. Our primary means of communication is Slack. We are also using Google Hangouts for our weekly sponsor meetings. Some lessons we've learned. Testing. We have learned that we can utilize emulators to test our project on different mobile operating systems. In the beginning, we will want a native Android or iOS user to test the associated task with his or her phone. This puts strain on members who had to test and finish up remaining tasks. Scheduling. Work schedules in everyday life causes scheduling conflicts. We have learned that we don't all have to be online at the same time. However, we all must be on the same page. Slack saves chat history, and we record our sponsor meetings. Each group member is expected to stay on track with the project. Sprint goal. Limiting the sprint goal too much can cause bottlenecking. Taking more time to define the sprint goal so that it is not too broad or restricting can help prevent this issue. This concludes our review. Thank you.